All right, everybody. So today we're looking at a thing called function notation for this lesson. Function notation. So when we've got functions, now we know what they are. We know how to say when it's a function or when it's not. Now we're going to learn kind of a way to write functions, how they are written by people actually working with math. So I want to welcome all of you to Math Adulthood. Up until now, you've been writing things as y equals something, and we call that our xy notation. So an example is y equals 2x plus 3. But that is not, I repeat, not, as I point into the camera, how people who actually do math, engineers and scientists and mathematicians, they don't write functions that way. They don't write it that way. This is for grade 9s and 10s, and you are past that. I want to welcome you into Math Adulthood. You are now going to write functions using function notation, just like it's done in the real world, where people are using math to solve problems. So we're going to take that y, and we're going to get rid of it, and in its place, we're going to use the letter f. Now, f stands for function. And in brackets, we're going to put an x, and the x is it's the input, essentially. So what we're saying is when we have those little brackets, we're saying x is going to be our input. So f of x is now what we're replacing y with, and the whole thing, the f with the x, that will be the y value. Our y values would take the place of the f with the x. The x is just there to show you that that's the input value. Okay, so a couple of things. How we read this, when I say that, I say f of x. Some people will say f at x, basically the same thing. F of x or f at x. That's how we're going to write equations now. Now this is just a linear equation, right? 2x plus 3, that's a straight line. Linear equation. Slope of 2, y-intercept of 3. Now, we use this function notation because it's a really easy way to show values that we're inputting. It also allows you to stuff one function into another function and have them work together. So, in your textbooks, you'll notice I made a little note right at the top. For the 11M class, this is in section 1.3 in your textbook. For the 11U classes, this is in section 1.2. Now the 11M class, you might notice we skipped a section, 1.2. In your book, we are going to squeeze that in, but for now we're just jumping over it. So usually we use F, because stands for function, but we can also name them other things. So if we're working with a bunch of functions at the same time, and we don't want to get them confused with one another, we can use other ones. So h at x, j of x, g of x are all really common. You can use any letter. Any letter would be fine. You probably wouldn't use y of x because that could confuse people because y is the one we like traditionally use and f of x replaces it. So I probably wouldn't use y for that, but anything else is fine. G is really common, h is really common, s is pretty common, h is pretty common. If we're talking like physics for the height of things. Okay, so now that you are math adults, we no longer use y equals something, we use f of x equals something. Let's do some examples where we actually practice this, and I'll show you how it helps us to sub things in to an equation. Let's put a little screen on that so we're doing it one piece at a time. So function notation is going to be used when we want to substitute values in for the x value. Usually we call it x, but in reality it's our independent variable, right? The variable on the x-axis. So often that's going to be time. When we've got a real-life equation, say we're graphing something, we'd usually have time on that axis. So if you were doing like math for space shuttle launches, things like that, most of the time most often you're using time as your independent variable. And that's going to be your variable on your x-axis. So let's try this out. Here's our function. So given f of x equals x squared minus 3x plus 1, that's a quadratic, right? That's a quadratic because my largest exponent of my term is a squared. So given this, and instead of writing y equals that, now we write f of x equals that. Find the value of f of x when x is 2 and when x is negative 3. So what I'm going to do is I'm going to take that equation and I'm going to sub in a 2, and then I'm going to take that equation and I'm going to sub in a negative 3. So let's see what that would look like. Here's our first one. I took that whole equation, and everywhere I saw an x, I subbed in a 2. And right here, f of 2 tells us that we're looking at this equation when x equals 2, we're trying to find out what y equals. So whatever answer we get will tell us that when x is 2, y is whatever. So you'll notice I substituted a 2 in here and a 2 in here, where my x's were. And now it's a matter of actually doing the math. So let's do it. 2 squared is 4. Negative 3 times 2 is negative 6. So we end up with 4 minus 6 plus 1. That's going to be negative 1. So that basically means our y value is negative 1 when our x value is 2. And you'll see I wrote on the side there, 2, negative 1 is a point on the graph. So when x is 2, y is negative 1. And so another way to write that would be to say just f at 2 equals negative 1. It's another way of saying y equals negative 1. But now instead of just saying y equals negative 1, we know by our function notation that we're saying when x is 2, y is negative 1. So this is a way that conveys a lot of information. Okay, let's try this at negative 3. Actually, I'd like you to try that on your notepad right now. I'm going to pause our recording. I'd like you to take 1 minute. I'd like you to try to do the exact same thing, but instead of substituting in a 2, try substituting in a negative 3. Go for it. Again. All right, so you substituted in negative 3, wherever the x was. And so you squared negative 3 and found it was 9. You found that negative 3 times negative 3 is positive 9. And then you added 1, so we end up with 19. So negative 3 and 19 is a point on the graph. And of course, you would write that by saying f negative 3 equals 19. That conveys the same information. Tells us when our input is negative 3, our output is 19. Okay, so that's function notation. Here is our second one. I'm going to do 2 more examples here. I'm going to try 2x minus 6. This is a linear equation. I'm going to do the lower one here when f is negative 1. And then I'm going to ask you to do the higher one. So when f is negative 1, I've got 2. Wherever there was an x, I'm going to put a negative 1 in there. 2 times negative 1 is negative 2 minus 6. It's going to be negative 8. So my points on my function, one of the points on my function is x value of negative 1, y value of negative 8. And I could say f of negative 1 equals negative 8. I'd like you to do the same thing now for the one just above, where you're finding f at 2. for this function, for this equation. Go for it. All right, so you would have said, let's put in a 2. Anywhere I see an x, 2 times 2 is 4. We'll end up with negative 2. So we've got a point when x is 2, y is negative 2. And for f of 2, that's going to be negative 2. Okay, let's try a few more of these, and then let's try them with a graph. I kind of want to whip through these ones pretty quick. And so I think I'm just going to do, I'll choose like one of each of these to do, because I feel like we're probably doing okay. For number 3, I say f at 1. So I got to put in a 1 everywhere there was an x. 1 squared is 1, times 3 is 3, minus 5 is negative 2. So f at 1 is negative 2. F at negative 2, I'm going to say 3 times negative 2 minus 5. Negative 2 squared, negative 2 times negative 2 is positive 4. Times 3 is going to be 12. Minus 5 takes me down to 7. Let's have a look at number 4. Number 4 has, looks a little more complicated. Let's just try the g at 4. So anywhere I see an x, I'm going to put in a 4. And you know my problem is writing 4s on this tablet for some reason. They always end up looking like 9s. 4 plus 1 is 5 squared. So we're going to do our brackets first. 5 squared is 25. Minus 2 is 23. Let's try number 5. Now you notice I did f at x, g at x, h at x. Those are just other ways to write functions. Once we've used f at x, if we're working on the same problem, we may want to name the other ones differently so that we can tell them apart. So h at 0, let's substitute in a 0. Zero minus 3 is negative 3, divided by 2, it's negative 1.5. Okay, so I hope those are all right. We're substituting in for x values, and then we're doing a bit of algebra. Let's have a look where we're trying to go the other direction. So we've got a graph here. And given this graph, and this is some sort of function, I don't know what the equation would be offhand, but some sort of function. And we want to figure out what f at 2 is, what f at 0 is, what f at negative 2 is, what f at 0 is, what f at 2 is, and what f at 3 is. So here's how we're going to do that. For f at negative 2, I'm going to look at, for an x value, I'm going to say x at negative 2. I'm going to look for that. So let's see. My x value of negative 1 is right here. Negative 2 is right here. So when x is negative 2, I'm going to go down to my function. Here it is. Okay, so it's right here on the end. Now I need to figure out what that y value is, because I know my x value is negative 2. What's my y value? Well, let's go across and see what we get. Looks like negative 1, negative 2, negative 3. So that's going to be negative 3. When x is negative 2, y is negative 3. I'd like you to have a look at the next one. When x is 0, what is y? I'd like you to type your answer into the chat if you know it, but don't hit enter yet. Type your answer into the chat, but don't hit enter yet. So when x is 0, what is y? Go for it. You can type that in. You can hit enter now. I'll do this one in purple. Okay, thanks, Emma. We have a few people that are in the same situation. So we might be in a little bit of trouble if I'm trying to use the chat too much, so maybe we'll just kind of push on here. If you were thinking 4, you were really close to correct, but you got thrown by the scale. So on this scale, we can see down here, we go down 4 squares to get to negative 2. So each 2 squares counts as 1 on this grid. So when x is 0, that's right here. Let's go up to our function. Here it is. It's this dot right here. What is y? Well, our y value is 1 there, 2 there. So this spot, my x value is 0, my y value is positive 2. So my x value is 0, my y value is positive 2. So f at 0 equals 2. Let's do the next one in black. When f is 2, what's y? Well, let's go over 1, 2. That's going to be this dot right here. I'm drawing in black. What's our y value? Let's look over to the y-axis. Looks like it's negative 1. And we'll do our last one in blue, f at 3. So x has got to be 1, 2, 3. Here's 3 on the x-axis. So let's find our function. We got to go up to find it. Here it is. So that's an x value of 3. What's our y value? Let's go across. Looks like we're at 2 plus 1 more square. Well, we know each square takes 2 squares to count up 1, so that's going to be 2.5. So when x is 3, y is 2.5. And I'll put that on my graph here as well. Okay, final thing I want to take you through. Well, there may be one more challenging type of problem. I think this is probably the final main thing for today. Okay, so we've got a function. We're going to call it g at x this time. G at x is 2x squared minus 5. So it's quadratic because it's squared. But wait a minute, hold on. We got something weird going on here. Look at this right here. We've got an m in the brackets instead of a number. So what do we do with that? When we see a number, we plug that number in anywhere there's an x. Well, it turns out you do the same thing with anything that's in the brackets. So if there's an m there, that means we plug in an m wherever there was an x. So we write 2m squared minus 5. And that's as much as we can do. I plugged in an m wherever there was an x. Now, you might say, well, that doesn't make any sense. Why did you even bother doing that? The reason is this is the first step in being able to sub functions into one another, which can be very useful and can get complicated. But let's have a look at our second one. This one says, put a 2x in anywhere there was an x. Okay, well, I'll write my function and I'll put brackets around where the x was, and I'll put a 2x in where that x used to be. Of course, we're going to have to apply our exponent here to everything in the brackets. It's only one term, so we can do that. So let's see. 2 squared is 4, x squared is x squared, like that. Now we got to multiply all that by 2. 2 times 4 is going to be 8 x squared. And I'm done. Anywhere there was an x, I substituted in a 2x, and then I simplified it. Well, how about this? Anywhere there's an x, substitute in an x squared. Whew, okay, well, there was an x here. So where there was the x, I'll put in a x squared. Well, x squared squared just means x squared times itself. So it means x times x times x times x. That's x to the 4. So now I can substitute functions into one another. There's a last one I want to show you. I'll scroll down in a moment, where we're actually going to subtract a function from one another using this function notation. Okay, here we go. It's this one right here. G at 5 minus G at 3. Ugh. Okay, that's tricky. So what this means is, let's take G at 5, whatever that works out to, and let's subtract G at 3, whatever that works out to. Well, G at 5 just means sub in a 5 anywhere there was an x. So we had 2 times 5 squared minus 5. So I put in a 5 where there used to be an x. For my second one, I'm going to put in a 3 wherever there used to be an x. And now I'm going to need to simplify these. So 5 squared is 25 times 2 is 50 minus 5 is 45. That's my first one. My second one, 3 squared is 9 times 2 is 18. Minus 5 is going to be 13. So we end up with 45 minus 13, and that's 32. So we subtracted one piece from the other. That's another skill we're going to need to be able to use. Okay. We're getting close to the end, so I want to leave it there, and I want to show you some stuff I'd like you to work on for tonight. So I'm going to just scroll ahead to our tasks, and I'll show you on EDSB what this stuff looks like. So for everybody, I'd like you to do a functions for error model tonight. We've done that before with trigonometry, so you're kind of used to it, but it's going to be for functions. I'll show you that in a moment. There's also Porcupine Puzzle, which is a quick little puzzle. It'll have a riddle to solve at the end. And then for the 11M class, some stuff for you to work on. And then for the 11U class, some stuff for you to work on. I know you've got your assignment due tonight, so that's your #1 priority, is finish that assignment and get that in. If you need to, tomorrow homework is going to be pretty light. So if you need to leave some of this until tomorrow to do tomorrow night, that's fine, because your assignment is your first priority. Okay, so I'm going to stop my recording and we'll head over to EDSB and I'll show you what things look like over there.